sometimes if you are using a very large unit, several orders of one unit, or using a very small fraction of a unit, we use prefixes. So if I say gigameter, it's a very large unit of meter. That means 10 to the power of 9 meter. That means billion meter. So giga, abbreviation is G. It means 1 billion times larger of a unit. It can come before any units. Or if I say mega, I'll be using uppercase M. It means a million. So mega liter is 1 million liter, 10 to the power of 6 meter. And if I say 1 kilograms, which I show with lowercase k, is 1,000. So can I say 1 kilograms is 1,000 grams? And you know, you have heard about 2K means year 2000, right? 2 kilobyte means 2,000 bytes. So hecto means 100. Hectogram is 100 grams. Deca, you know, decade is 10, right? So deca is 10. So if I say 2 deca grams, it means 20 grams. And deca, abbreviation for deca, is DA. How about fractions of a unit? A small, tiny amount of a unit. If I say the distance is 1 decimeter, you already heard decimeter. It means 1/10 of a meter. And we use D for deci. How about when I say centimeter? Is centimeter 100 of a meter? But centi and deci and deca, all of these prefixes can come before any units. If I say decigrams, it's 100 grams. If I say deciliter, 100 of liter. So these prefixes can come in front of any unit and they have a meaning. What's the meaning? Right in here. If I say milli, it means 1,000. If I say micro, the thickness of my hair is, let's say, 2 micrometers. It means it's 1,000,000 times smaller than 1 meter. And let me turn off the sound of my email, which is going to be distracting to you in just a moment. I'm going to turn off my speaker. Okay. You have probably heard about nanotechnology. It means you're dealing with the small dimensions. 10 to the 9. That means 1 billion times smaller than the unit. Let's say nanometer. It's 1 billion times smaller than 1 meter. And if I say pico, it's trillion times smaller than the unit. Picoliter is trillions of a liter. And there is abbreviation P for pico, N for nano, micro has mu, the Greek alphabet, and M for milli. I'll give you an access to this table. You will learn by repetition. You don't have to sit down and memorize them. So how about units for volume? How about units, let's say, for volume is cubic meter, because the unit for length was meter, and if you are measuring volume, you have to multiply the length and width and height together. So meter times meter times meter becomes cubic meter. How do you measure area, let's say, of a cube? You multiply the dimensions. Not cube, I'm sorry, area of a square. You multiply width times length, m times m is m2. So the unit for measuring area is going to be square meter. The unit for measuring volume, and these are international units, is cubic meter. And density, how about density? Did we define density as mass per volume? And we already said mass is measured for international unit. The unit of mass is kilogram. You want to divide mass by volume. The unit of volume is cubic meter. So kilogram per cubic meter is going to be the unit for density. How about the speed? What's the meaning of the speed? Is speed defined as distance per unit time? The unit of distance, meter. The unit of time, second. So meter per second is the unit to explain speed. Acceleration, what is the definition of acceleration? If you remember your physics, acceleration is change in a speed in 1 unit of time. So change in a speed. Speed itself is m over s. And we're measuring change of a speed in 1 unit of time. So define meter 2 times by second. So do I get meter over a square second? How about force? In physics, you calculate force. The formula for force is mass of the object, which is moving, times its acceleration. So mass of object is kilograms. Acceleration is m over s2, so kilogram meter square second. That is the unit for force. Kilogram, 1 kilogram meter, 1 kilogram meter per square second is defined as unit of force, which is called Newton. Now, what is the definition of pressure? Force divided by unit area. So this is the unit of, I'm sorry, it jumped on me, sorry, okay. So all I have to do, this is the unit of force. Oh, don't do that, go back, no, go back, no, go back.
When you're teaching about metric measurements, at some point you're going to be talking about cubic meters. One of the things...
Okay, I'm sorry. There was a problem. I want to go back to my PowerPoint. And I was here. So pressure is force divided by unit area. And this is the unit for pressure. That's the definition of Pascal. Kilogram per meter per square second is 1 Pascal. And unit of energy, what do we know about energy? That's force times distance. So all we have to do, multiply force, which is this formula, by distance, which is m. So we get kilogram, m2, kilogram, m2 over a square second. And that's the definition of joule. The unit of energy is joule. 1 joule is equal to 1 kilogram per square meter per square second. All right, let's go to the next slide. So we said we measure density as mass over volume. So in lab, we measure the mass in grams, and the volume we measure in milliliter. Is there a relationship between international unit of density, which is kilogram per square meter? Yes, these are related together. Every gram per milliliter is equal to 1,000 kilogram per cubic meter. we will do some conversions using these relationships. And as you might know, that cubic centimeter and milliliter are related together. 1 cubic centimeter is 1 milliliter. So these are two different names for the same amount, for the same value of density. So cubic centimeter is the same as 1 milliliter. So by that, can I define density as mass per volume? That means take the mass divided by volume. Do you remember you did this to determine the identity of a metal? In Chem 2A, we gave you a cubic made out of a metal. You measure the mass and you measure the volume. You measure the volume by increased volume. You had water in a graduate cylinder, you measure the volume, and then you drop the metallic cube inside that cylinder. The total volume went up. The amount of increased volume was volume of the metal. So if I give you a simpler formula, can I use D for density is equal to M for mass divided by volume V. So that's a simple formula for density, mass over volume. And if I ask you to solve this problem, we are giving you the density of platinum metal. Can I say we are giving you the amount of D? And we are giving you the volume. So this is the volume. And we are asking you to calculate the mass. So in this equation, you have one equation, one unknown, you can easily solve it. How would you solve this problem? Would you say that density is equal to mass over volume? And what is not known is mass, but density and volume is already known. So can I solve this equation for mass? I can add 1 here on the bottom, so any number divided by 1 is the same. And then do cross multiplication. 1 times M is equal to what? Is it equal to D times V? So this is equation for mass. Mass is equal to density times volume. Do we have the volume? Do we have the density? So all I have to do now is to replace these two values. Density, 21.5 gram per cubic centimeter. Volume, 449 cubic centimeter. Make sure when you are doing problem solving, as we said before, please do write the units. If you don't write the unit, you might make an error and you won't catch it. By writing the unit, do you see cubic centimeter is on the bottom of ratio? This is on the top, they cancel each other. So what am I left with? Grams. Is gram the right unit for mass? If it is yes, then you can do your multiplication or other calculations. If you don't get the right unit, if you get cubic centimeter for mass, you know there is something wrong. Then you have to go back and correct your errors.